Welcome back to lesson on improper integral. We are going to solve this 10 problem for improper integral. What is about improper integral? Improper integral is about modifying the fundamental theorem of calculus to obtain a result. Let's go to review this thing. When you have the fundamental theorem of calculus, you talk about a closed interval AB. You talk about a function f that is continuous on the closed interval AB. The AB interval is a finite interval. And what you say is that the integral from A to B, from x equal A to x equal B, of f of t by ddt is equal to f of b minus f of a, where f of x, the derivative, is f of x. This is what it says, the fundamental theorem of calculus. The fundamental theorem of calculus, what it says, instead of finding the Riemann sum of the function little f, find the antiderivative, and in the extreme point v and a, find the value of the antiderivative at the extreme point v and a, and subtract this value. This is what it says, the first fundamental theorem of calculus. Now we want to make integrals where the interval is from a to infinity, so it's not a finite interval, and we want to find the integral of functions that maybe they are not continuous at the point A. So how we will do? Well, imagine this is the interval AB, and the function is defined in the open interval AB. It's not defined in A, imagine. How we will do this integral from A to infinity? We will do the integral in two parts. We will imagine that we are doing the integral from h to an intermediate point C between A and B. We will do this integral, meaning that we will find this area. Once that we will do this integral, we will make the limit when the h, this point, goes to A, approach to A, but it will approach to A from the right, so it will approach to A positive. Okay, once that we will do, and this C is an intermediate point, we will do the limit from Z to V, from Z to V. And once that we will do this area, we will make the limit when V tends to infinity. And in this way, we will do the integral from A to infinity for the cases when the function is not defined at the point A, and also is not continuous on the closed interval AB. Let's go to do problems. Okay, the first problem is say, determine whether the improper integral from 2 to infinity x minus 4 converge or diverge, and evaluate the integral in case that it converge. So this function is the function 1 divided by x is 4, the file on the open interval. On the 2 there is no problem. On 2 no, there is no problem, but the interval, it goes from 2 to v. At v it will go to the infinity, so it will be an infinity interval. At 2, the value at 2 is 1 divided by 2 to the 4, so it's 1 divided by 16. So this is 1 divided by 16, and the function will do like this: 1 divided by x to the 4, 1 divided by x to the 4. And what we want to know is if this area, this height is 1 divided by 16, and what we want to know if this area converge or diverge. So what we will do, we will do the integral from 2 to v, and we will make the point v, to go to infinity. Maybe the point v is here. It will go to the infinity. We will do the limit where v goes to infinity of 1 divided by x4 ddx. So this is the limit when v goes to infinity of the integral of x minus 4 from 2 to v ddx, and this is equal x minus 3 divided by 3, evaluate between 2 and v. And this is the limit when v goes to infinity of v minus 3 divided by 3 minus 1 divided by 2 raised to the 3 multiplied by 3. So this is the limit when this goes to infinity of 1/3 v cubed minus 1 divided by 2 raised 3 is 8, 24. Okay, and what happened when b goes to infinity? When b goes to infinity, this goes to 0. So the integral is negative. When b is minus 1 divided by 24, which is not possible. Why? Because cannot be negative. I see the integral, the function positive. Where did I make the mistake? Is from 2 to v. From 2 to v. Let me see. I did a mistake. Where did I did a mistake? Oh, x minus 3 divided by minus 3. So x minus 3 divided by minus 3, and there is a minus 3 here. And now I know where is the mistake. Now let's go to correct. So now it will be, when it will be minus 1 divided by v3 minus, and the 3, minus is positive, minus is positive, plus 1 divided by 2, 3 multiplied by 3. And now, yes, this, when v goes to infinity, this will go to 0, and the integral will be a finite number, so it will converge. Let's go to the next. Problem 2 says determine whether the improper integral, the integral from 1 to infinity, of this function, x minus 1/5, converge or diverge. So we will do the integral, and we will see what happens. So the integral that we are going to do is the integral from 1 to infinity, x minus 1/5 ddx. This integral is the limit when of the integral from 1 to v, and now we make v tends to infinity of the function d dx. What is the integral of this function? The integral of this function is x minus 1 5 plus 1 divided by minus 1 5 plus 1. Minus 1 5 plus 1 is 4 fifths. So it's x 4 fifths divided by 4 fifths. Evaluate between 1 and v. Now the 4 fifths will appear like 5 fourths. 5 fourths, the 4 fifths will appear like 5 fourths. And it will be b, evaluate at v will be b 4 fifths minus evaluate at 1, it will be 1 raised to the 4 fifths, that is 1. So now I have to do the limit when v goes to infinity. When v goes to infinity, v 4 fifths will go to infinity also. So the limit will go to infinity. These problems say, determine if this integral, the integral of this function e minus 4x, the integral from 0 to infinity and infinite interval, will converge or will diverge. So we evaluate the integral. We don't need to do any limit at 0 because the function is well defined as 0. At 0, the value of the function is 1. So let's go, but the interval is infinity interval. So let's go to do the integral. So the integral from 0 to infinity of e minus 4x dx, we take the limit when v goes to infinity from 0 to v, but we make v tends to infinity, e minus 4x. What is the integral? What is the antiderivative of e minus 4x? Is minus 1 for e minus 4x. Evaluate between v and 0 is minus 1 for e minus 4v plus 1 4. When you evaluate at 0, e0 is 1, minus minus become positive, it would be 1 4. When v goes to infinity, e minus 4v goes to 0, so the total result will be 1 4. So it will converge. Let's go to the next. Okay, now problem 4, it say, determine whether the improper integral from minus infinity to 0 of the function 1 divided by 1 plus x squared dx converge or diverge. Okay, this function 1 divided by 1 plus x squared, when x equals 0, the function have the value 1. When x is bigger, smaller than 0, the function is smaller than 1, and it goes to 0. The integral from minus infinity to 0 represents the area under the curve from minus infinity to 0. What is the problem here? The problem is the function is well defined at 0, no problem at 0. The problem is that we don't know if this area converge or diverge. To make it possible that this area, to make it possible to know if this area converge or diverge, we take a point v and we make the integral from 0 to v, from v to 0. So we make the integral of this function from v to 0 of the function 1 plus 1 plus x squared ddx. And we take the limit when v goes to minus infinity. So the v will be moving to minus infinity. And now the area that is here, it will start to grow. When it goes to minus infinity, the area will be a finite number or will be an infinite number. So we know that the derivative of arctangent of x is 1 divided by 1 plus x squared. So the antiderivative of 1 divided by 1 plus x squared, the integral, is arctangent of x. So this is equal to the limit when v goes to infinity of arctangent of x evaluate between v and 0. The function arctangent of x does like this. This is the function, the inverse function of tangent x. The inverse function of tangent x, arctangent of x, will approach to pi divided by 2 as the function of arctangent of x approach to infinity. So as you move into the infinity, the value of the function approach to pi divided by 2. And as you move into the minus infinity, it will approach to minus pi divided by 2. So this is arctangent of x, the inverse of tangent of x. So it will be the limit when v goes to infinity of arctangent of 0 minus arctangent of b. And arctangent of 0 is 0. The inverse arctangent of 0 is here. Arctangent of the point 0 is 0. So it's the limit when v goes to infinity of minus arctangent of b. But when v goes to infinity, arctangent of v goes to minus pi divided by 2. So the limit will be pi divided by 2. So that means that this area here, this area that we are finding, is a finite area. And the value of this finite area is pi divided by 2. And it's a positive area. Yes, it's positive. The next problem, it says determine whether the proper integral from 0 to 4 of 1 divided by a square root of x did the x converge or diverge. What is the problem here? The problem here is that at x equals 0, the function is not defined. 1 divided by square root of x is not defined at x equals 0. Then we need to do this integral. If we represent 1 divided by square root of x, will give you a function like this one. It will give you a function like this one. So it will go to infinity when x approach to 0, will not be defined for x negative. It will go to 0 when x goes to infinity. But the evaluation that they are asking me if converge and not converge or diverge is between 0 and 4. So the problem is at 0. So I need to choose the point V, make the area from V to 4, and once that I have the equation for the area A that will depend on V, I will make the limit when V goes to 0 plus. So I will make to approach the V to 0, and I will try to find what is this area. What is all this area when V goes to 0? 0 positive. So let's go to do it. So the integral from 0 to 4 of 1 divided by square root of x dx is the limits from V to 4 when V, from V to 4 when V goes to 0 plus. So the area will be increasing, and increasing decreasing to infinity or increasing to a finite number? Well, let's go to do it. It will be the integral from v to 4 of x minus 1 half. The integral of x minus 1 half is x minus 1 half plus 1, which is x 1 half divided by minus 1 half plus 1, which is 1 half, which is divided by 1 half. It will appear the 2 here. So evaluate between 4 and b will be 2 times the square root of 4, which is 2 by 2 is 4, minus 2 times square root of b, minus 2 times square root of b. When v goes to 0 positive, the square root of b goes to 0. So the value of the integral will be 4. So this area that is here in red, this area is a finite area between 4 and between 0 and 4. And we did the problem. Let's go to do the next one. The next one is say, now the function is 1 divided by x. It's a different function. The function 1 divided by x, if you represent the function, it is like this. 1 divided by x is a function that does like this, and in the negative quadrant, in this quadrant will be 1 divided by x. 1 divided by x is this function. This is the function. When x is 1, y is 1. When x is 1 half, 2, y is 1 half. When x is minus 1 half, x is minus 2. So, let me write here minus 1 half. When x is minus 1 half, y is 2. And when x is minus 1, y is minus 1. When x is minus 2, y is minus 1 half. Okay, but the integral is from 0 to 5. So I would choose the 5 here. At the point 5 is define the function. The problem is at the point 0. So I will do the integral from v, any point v, to 5. So I will find this area. And later on that I find the area in terms of b, I will say let's go to do the limits when v goes to 0 positive of this area. It will be a finite number or it will be an infinite number. So we are pretending to find the area from 0 to 5, from 0 to 5, or this area, from 0 to 5. It will be a finite number or infinite number. So let's go to do it. The integral from 0 to 5 of 10 divided by x is the limit when v goes to 0 positive of the integral from v to 5 of the function. This function, the integral is natural log of x, so it's 10 times natural log of x evaluated between b and 5, so it's the limit when v goes to 0 plus of 10 times natural log of 5 minus 10 times natural log of b. When v goes to 0 plus, natural log of b goes to minus infinity. With this minus will go to plus infinity. So this area, the area that is here, is not a finite area. The integral will diverge. Okay, let's go to the next problem. And the next problem say determine whether the improper integral from 0 to 2 converge or diverge. What is the problem here? The problem here is not it's at 0, while 0 minus 1 is minus 1, and the cubic root of minus 1 is minus 1. No problem. The problem is at x equal 1. Between the interval 0 to the point 1, it's here. And at the point x equal 1 is not defined the function. So we need to go to do the integral in two parts. We have to divide from the integral from 0 to 2 to the integral from 0 to 1, but when v approach to 1 negative, and now we have to do the integral from 1 to 2, or from z to 2, when z approach 1 positive, or the same b if you want, or c. Let's go to do a picture. The picture is like this. This is the graph of the function as you approach to 1 from the right, so this is the v. As the v goes to 1 negative, the v goes to 1 negative, the v goes to here in the left side of the 1. From 0 to 1 minus. So let's go to do it. So it will be the integral from 0 to 2. 0 to 2. 2 is here. 2 is here, and the function will have a value. 0 is here. And the area that we have to find is this area. This area, we don't know it will be infinity or it will converge, and this area. So from 0 to 2 we need to split the integral. So the function is the function 1 divided by cubic root of 1 divided by the cubic root of x minus 1. So we will do the integral from 0 to 1. But instead of doing 1, we put it b, and we put the limit when v approach 1 from the left. So is the limit when v approach 1 minus of what? Of the function. 1 divided by s cubic root of x minus 1 ddx. And later on, we have to do the integral, the area, from 1 to 2. But at 1 is not defined, so we need to do the limits. So we put a point z here, c, and we make the limit when z approach 1 positive, 1 to the right of what? Of the function, who is the function 1 divided by the cubic root of x minus 1 ddx. Now, doing this integral is not difficult. It's been done here, and the integral appears to be 0, so it will converge. The amount of area that are here below the curve from 0 to 1 negative is the same amount of area that is from 1 to 2, and is 3/2. You can do the integral, very easy integral. You have to do the integral and the limits, and the integral will be 0. Okay, let's go to the next problem. Okay, let's go to do this problem. Let's go to do a pitfall here. Let's say that you do it like this, the integral from minus 1 to 2 of 1 divided by x cubed ddx equal the integral from minus 1 to 2 x minus 3 ddx equal the integral from minus 1 to 2 x minus 3 plus 1 minus 2 divided by minus 2. The integral is x minus 2 divided by minus 2 between minus 1 and 2. So it will be minus 1 half that multiply 1 divided by x squared evaluate between minus 1 and 2. So you will say that this integral is minus 1 half 1 divided by 2 squared minus 1 divided by minus 1 squared. So you will say that this integral converge and the amount of area is 1/4 minus minus plus 1. Well, this is wrong. Is wrong. Why is wrong? The problem here is that 1 divided by x cubed is the function that does like this, is not defined at 0. At 0 is not defined because you cannot divide by 0. It's negative here when x is minus 1, minus 1 by minus 1 by minus 1, 1 divided by x cubed is minus 1. So this is the function 1 divided by x cubed and it's not defined at 0. So if I want to find the integral from minus 1 to the point 2 that is here, 1 and 2, you cannot do what I have done. You need to do it slowly. Slowly. You need to understand that here there is a discontinuity at the 0. So what you will do is first you will do this area with v approach 0. And later on you do the other integral when z approach 0 positive. So let's go to do the integral now. The integral from minus 1 to 2 of 1 divided by x cubed v dx, you have to do it in two parts, because if you do it in one part like I have it down here, it's wrong. You are jumping at discontinuity. You don't know what is happening at the discontinuity. So is the limit when you split the integral into two integrals. In the first one, you are going to find from minus 1 to 0. And in the other part, you are going to find from 0 to 2. So it's from minus 1 to 0, but instead of writing 0, you write here v. V, and you make the limit when v goes to 0 minus 0 from the left. And here, instead of 0, you write c, let's go to write c, and you make the limit when z approaches 0 positive. Oh, now I can do the integral. It will be the limit when v goes to 0 minus of the integral from minus 1 to v of 1 divided by x cubed ddx plus the limit when z approach 0 positive of the integral from z to 2 of 1 divided by x cubed ddx. Of course, this integral will depend on v, will depend on this point v of wherever you have the v. But when you make the limits when v goes to 0 minus, it would be the area between minus 1 and 0. It would be this area, negative area. So to do this integral is not difficult. It will be the limit when v goes to 0 minus of what? X minus 3. What is the integral, the antiderivative of x minus 3 is x minus 2 divided by minus 2. X minus 2 divided by minus 2 between minus 1 and v. And this integral is the same as the limit when v goes to 0 minus. What is this thing? Is minus 1 half x squared. Okay, so is the limit when v goes to 0 minus of minus, let me put it this minus, let me put it here, 1 divided by 2 squared, 1 divided by 2x squared, and let me put the 1/2 here, 1 divided by x squared, and let me put the 1/2 here, between -1 and v. So it would be -1/2 multiplied by the limit when v goes to 0 minus of 1 divided by v minus 1 divided by -1 squared. So it will be equal -1/2. When v goes to 0, this goes to minus infinity. And this is, of course, 1. So minus infinity, so this will go to minus infinity, will diverge. And the other side of the integral will also diverge. When you do the integral from when c goes to 0 plus 0 to 2, from 0 to 2, it will diverge also. So at the end, the integral will diverge, and the total result here is here, is here, is here. Wow, very short, huh? Very short. Okay, let's go to do it in the next problem. Okay, this problem says find the integral from 0 to infinity of this function. Who is this function? This function is a function who is not defined for x negative. Oh, the square root of x negative doesn't exist. So the function is defined when x is strictly bigger than 0. Because at 0 is also not defined, not because 0 plus 1 doesn't exist, it's because the square root of 0, 1 divided by square root of 0 doesn't exist. So the function is not defined at 0. So the problem is at the point 0. So the function is not continuous at 0. It doesn't exist at the point 0. So we need to do the integral like doing the limit. Well, it's here. We do the limit 0 to 1. The number 1 is arbitrary. You can choose the 2, the 3, the 4. We choose the 1 because it's easier to evaluate from 0 to 1. So we split the two integral. The function will do like this. Let's go to try to make a picture of the function. The function is not defined for x negative, is not defined for 0, and is defined for x positive, and we'll do something like this. So what we want to do is the area that is here under the curve, this area. This area will converge or will diverge. So the 0 is the point. So we need to choose a point V here, B, a point 1, a point C here. So this is the setup of the problem. So we will find the integral from V to 1, this area. So what is the integral from V to 1 of the function? What is the function? The function is 1 divided by square root of x multiplied by x plus 1 ddx. And we will do the limit when v goes to 0 minus. And later on, we need to add the area from 1 to z of the function. 1 divided by square root of x, x plus 1 ddx. But we need to make the point c goes to the infinity. So we need to take the limit when c goes to infinity. So in the first part, in this area, we find this, in the first integral, we find this area that depends where you take the point v. And in the second part, we have an area that is from 1 to z, this area from 1 to z, so this area depends on z. And in the second part, we are going to take the limit when v goes to 0 minus, and here we are going to take the limit when z goes to infinity. And now we have done the integral. As I said, the point 1 is a point that you stop by convenience. You can stop at the point 2 if you would like to do it like this, only that the the evaluation will be more complicated, but will be exactly the same value. So if you do this and you do a change of variable, this is the integral. If you do the change of variable square root of x equal u, um, the the change of variable will take you to an arc tangent of a square root of x. You evaluate between v and 1 and between 1 and c. You make the limits, and this limit will be pi. So this area converge to a number. All this area from 0 positive to infinity will converge to a number, and the number is pi. We did this problem 2 or 3 times at class. We did it during the class, we did it in a quiz, and I ask you again to do it in an exam. Oh, okay, let's go to the last problem. Say, show the surface of Gabriel horn S equal to pi, the integral from 1 to infinity of this expression. Show that the surface is S. So what it say here, then prove that this integral diverges comparing to the integral. Okay, let's go to do it. This is an interesting problem. Okay, let's go to do it. Let's go to do it. What is the surface area that he is asking us to see? The surface area, imagine you have the curve 1 divided by x. 1 divided by x at x equals 0 is discontinuous. This is 1 divided by x. You take the point v here. Imagine that you are calculating the area from v to infinity. So you are calculating the integral from v to infinity of 1 divided by x d dx. What is asking you? Is asking you what is the surface if you revolve this function through the x-axis. If you revolve through the x-axis, you will have this. Let's go to revolve it. You have this function. Okay, revolve it, and now you create a three-dimensional object that have a surface area, and the surface area is here. This is the surface area, so we need to find this surface area. So the surface area is the surface that is like a ring, like a wedding ring, and you have to find the surface of the wedding ring. And the area of the surface of the wedding ring is 2 pi r by ds, by this length. If you cut it, you will find this surface. This is ds, and this will be 2 pi r. Okay, 2 pi r by ds. So 2 pi r is the function. The r is the function 1 divided by x, and vds is the arc length of the function, and the arc length, if you remember, is the square root of 1 plus y prime square. In this case, dds is square root of if the is 1 plus y prime of x v dx. This is the length. So I have to plug in here the dds. Here I have to plug in the dds. So it will be a square root of 1 plus. What is the derivative of 1 divided by x? is minus 1 divided by x. Square is 1 divided by x4. Is minus 1 divided by x squared, but the square it will be positive, d dx. And this is the integral, this is the surface area. So the surface area is this integral is equal to 2 pi by the integral of 1 divided by x square root of 1 plus 1 divided by x4 d dx. Okay, so we have done the first part. Let me read it again. Yes, 1 divided by, this is the first part. I have found this part, that this is the surface area. Now it say, then prove that this integral diverge comparing to the divergent integral 2 pi 1 to infinity 1 divided by x. Well, to compare this integral, we will do this thing. So, this is the surface area. Now, this is something that is always bigger than 1. So this integral, the integral of 1 divided by x square root of 1 plus 1 divided by x for d dx, this integral is bigger than the integral of 1 divided by x d dx. Why is bigger? Because this factor is here. The 1 divided by x is here. But this factor is an alpha factor. It's a factor that depends on x, but it's always bigger than 1. So this is bigger than 1. Because this integral diverge, because you know by the PCs that this integral diverge, you remember, from 1 to infinity, this diverge. This one will diverge, and the problem is solved. So why this one will diverge? Because this area is bigger than this area, so it will diverge. Let me read what it says here. Yeah, more or less that this term is always bigger than this term, because this diverge, this will diverge. Okay. Well, the evaluation of this problem is the following one. When you have the function 1 divided by x from 1 to infinity, 1 divided by x, 1 divided by x from 1 to infinity. When this is 1, this is 1. When it's 2, this is 1 half, etc. The area that is here diverge. So the integral of 1 divided by x d dx from 1 to infinity diverge. The other evaluation that we have is what happened with the surface area. The surface area is the integral from 1 to infinity of the expression that we found. And the expression that we have found it by summing the areas of a ring. And the area of the surface area of a ring is 2 pi r of x, 2 pi r of x by dds. And putting the information that is here, it would be the integral from 1 to infinity of 2 pi r of x is 1 divided by x, and d dx is the square root of 1 plus minus 1 divided by x squared y prime square d dx. And this integral diverge. The other evaluation is what happened with the volume that is inside the figure. What happened with this volume? The volume inside is another calculation. You can use this method. This method will say that the volume is the small volume of a disk will be pi r squared by d dx by d half. So this is the disk, this is the disk, this is the radius, and this is d dx, and here is the function. Here is the function, okay? Here is the function. So what is this sum? The small volume is pi r squared 1 divided by x is the function. The function is r is 1 divided by x is the value at any x of the radius. 1 divided by x squared by d dx. So this is the small volume, and the total volume is the sum of all these terms. Pi r squared pi 1 divided by x squared by d dx from 1 to infinity. Oh, and this volume will converge or will diverge? This volume converge. So it's strange that the volume converge to what it will converge. Well, it will converge to pi, the limits when v goes to infinity of the integral from 1 to v of 1 divided by x squared d dx, so it will be pi by the limit 1 divided by x squared is x minus 2, x minus 2 is x minus 1, is 1 divided by x between 1 and v, so it will be minus pi 1 divided by v minus 1 divided by 1. So it will be pi 1 minus 1 divided by v. And the limits when v goes to infinity will be pi. Wow! So the volume is finite and the volume have pi. The surface area is infinity. And this area here, this area that is under the curve is also infinity. And these are the results for this surface, for this function. It's called the surface area of Gabriel Horner. Okay, that's all.